Alrighty, we are looking at 4.08 exit ticket for 1024. Let's go ahead and get started. First up, we have our little warm-up, which is how are the pumpkins different? Well, just for fun, just for having a little bit of a laugh. We're just enjoying the season. You know, one's filled, one's not, right? So you can clearly see the main difference is that one is filled and one is not. So we're hoping that you guys are having a great time in October, Halloween being upon us, and among other things, eventually Thanksgiving. So it's just that time of the year where we want us to be as relaxed as possible, right? And being relaxed, this is the lesson for Friday, so we want you to be prepared to do the following. We're going to determine the perimeters and the areas of rectangles and triangles, along with polygons and composite figures in the coordinate plane. So we're going to go ahead and review distance really quick, and then do some examples with perimeter and examples with area. All right, starting with the coordinate plane, we want to use the distance formula today. There are other approaches to this beyond the distance formula, although if you're thinking of Pythagorean theorem, just be aware that that is technically still distance formula. It's just looking at it from a different perspective. I'm going to focus on the formula itself because that's a standard, and we want to make sure that you are prepared to utilize it in all of the problems for this assignment. So let's start with the distance between A and B. Firstly, it would help if we label the points that we're going to end up using, either on the diagram or somewhere on the side. I'm going to go ahead and put x1 and y1 right here, and I'm going to put x2 and y2 right here. And that allows me to know what am I going to plug in where in the distance formula. So the distance formula is going to be the square root of the sum of the squared differences of these coordinates. So we have x2, which is 4. We're going to subtract a -3. I'm just going to write it out like this, actually, and I'm going to show you kind of why. 4 minus -3 plus, we have our y coordinate, so that would be -1 minus 2 quantity squared. So you might notice that you have negative, negative. That is not good. We do not want that. So oftentimes is what we're going to do, and you'll see me do this every single time in the video. You have 4 minus -3. We're going to make that a positive. Make that a positive. If it's minus minus, you make it positive. All right, so here we go. We have a 7 quantity squared. We have a -3 quantity squared, and you got to remember to take the square root of all of that. And let's go ahead and fix the square root symbol there. There we go. So now we have the distance is going to be 49 plus 9, and we're going to take the square root again of all of that because we haven't gotten rid of that square root just yet. So here we have 58. 58. So we have the distance now of the figure, square root of 58, and we can input that in and get an approximate value for that. That is going to be approximately 7.62 units. That is the distance of that particular segment approximately in the coordinate plane. That is how we utilize the distance formula. All right. So let's go ahead. We're going to have a series of problems we're going to practice involving the perimeter and area of figures, right? So let's start by looking at the perimeter of a hexagon. Now, this is a regular hexagon, right? So when you have a regular hexagon, that means that every single side is going to end up being the exact same length. So that allows you to conclude that if you can figure out what the length of one of the sides is, like CD for example, you can simply multiply it by the total number of sides once you calculate the length of CD to get the whole perimeter of that figure. And so that is going to be our strategy. We want to figure out the length of one side of this particular hexagon. So in order to do that, we can go ahead and figure out the length of CD. On the diagram, I'm going to go ahead and let this be my x1 and y1. Let this be my x2 and y2. So here, calculating that length from C to D, my x2 is 8, my x1 is 2, so I have 8 minus 2 quantity squared. My y2 is 10, my y1 I should say. Apologies for that. I just wrote that as y2 for some reason. So we have 10 minus 2, that's going to be right there. Very good. So now we can simplify that. We have the square root of, in this case, 6 quantities squared and 8 quantities squared. We simplify that. The 6 squared is 36. 8 squared is 64. So we're left with the square root of 100, which is just equal to 10. So the length of one side of the hexagon is 10. We know that there are 6 sides, 6 total sides. So to calculate the perimeter of the figure, I'm just going to take the total number of sides and I'm going to multiply that by the actual length of one of the sides. So this gets me a perimeter of 60 units. There we go. Alright, so I calculated the length of one side using the distance formula. I made sure to watch myself as I'm filling out the distance formula. I caught my notation issue on the slide or on the graph over there on the left. Fixed that issue, simplified, and took the square root, and voila, we have our answer. Let's take a look at a triangle now. Now, in that last example, we only had to find the length of one side in the coordinate plane. But here, we're going to have to figure out the length of all 3 sides. And then we just need to add them up together to get the perimeter that we need. So let's go ahead and do that now. Now, this is broken into 2 slides because there's 3 sides we have to find. We're going to start with red here because it seems to be, or some type of pink color, seems to be my preferred color. So we're going to start by labeling A as x1 and y1, making sure they're correctly labeled, x2, y2. And I'm going to calculate the length of AB first. Okay, so based off of what they've given me here, we've got x2 is 3 and x1 is -2. So we have 3 minus -2. I did say I was going to write that out just to show it. And then y2 is 0 and we have y1, which is 3. Remember what I said about this. Negative, negative is positive. Change it to an addition sign there. So that gets me a 5 squared and a -3 squared, and I am taking the square root of both of those. So now I've got 25 and I've got 9, and I'm going to take the square root of those two. That gets me the square root of 34. So I have the square root of 34 for my length for AB. Now I'm going to point out that we want to go ahead and leave in root form until the end. You don't want to approximate it now. You want to approximate only at the very, very end. That's what we want to watch out for. Let's go ahead and use blue now for BC. I'm going to name that x1, y1, and this will be my x2, y2 like before. It's just in blue now, so we've got BC. And we're going to go ahead and figure out what that square root is. So we've got x2, which is 3. x1 is a -4. y2 is 0, and y1 is -3. So you see I wrote them out like that, but we want to make sure that we change that to addition for both of those because they were negative negatives. Alright, so here we'll have a 7 quantity squared. We're going to go ahead and simplify that right there as a 3 quantity squared. So here we've got 49, here we've got 9. And we're going to simplify that now as 58. So that is the square root of 58. That is the length of BC, right? So we have AB's length all the way down as we've been simplifying it. And now we have BC's length as well. So now we can find the third and final side in the next slide. I suppose I will use green for that. So here is A to C. And I guess I'll go ahead, it doesn't really matter. Maybe I decide I'm going to use this as x1 and this as y1, and then this will be x2 and that'll be y2. So we have A to C. take the square root, straighten that out there. So x2 is -4, and we're going to subtract -2 quantity squared, plus our y2 is -3, minus our y1 is just a 3, square that. Once again, negative negative is positive. So we have AC is equal to the square root of -2 quantity squared plus -6 quantity squared. So that means that AC is going to equal the square root of 4 plus 36. -2 squared is 4, -6 squared is 36. That simplifies to the square root of 40. Again, I'm going to leave it in that form until I get to the very, very end, which now I'm ready to do. Okay, so I have all three sides. We already calculated what they are. Remember that AB was the square root of 34. BC was the square root of 58, I believe. And then, of course, we have AC, which is the square root of 40. So we have all three of those. So now we can go ahead. I'll just use black here. To calculate the perimeter, we have to combine AB with BC with AC to get our perimeter. So we have the square root of 34, square root of 58, square root of 40, and then that can be an approximated perimeter as a result of that. Okay, so when we combine all of those, approximately we get 19.77 units. So that means I'm kind of leaving it to 2 decimal places because it's an approximate perimeter of the triangle. Alrighty. Now that one took a lot more work than the regular hexagon, right? So sometimes when using the distance formula, it can certainly do that. The second part is the area portion of the lesson. Here, I remind you of the area formulas of a rectangle and a triangle, right? Base times height, or half base times height. So we're going to apply that to a problem like this in the coordinate plane. We have a rectangle in the coordinate plane, and the vertices are listed out on the left there. And what we really need to do is we actually only need one single length for the base. And there's 2 options, or one single length for the height, and there's 2 options. So we don't have to find all 4 side lengths, thank goodness, right? And even if we did, they would actually be the same because the rectangle's opposite sides are equal. So we just have to find 2 lengths, actually, and then use the area formula. So let's go ahead and do that. Now you have a choice on which one you want to find. For example, I think I'm going to go ahead and find AB versus CD. Okay, so AB, I'm going to go ahead and find that. I'm going to treat A as x1, y1, and I'm going to treat B as x2, y2. So to calculate AB using the distance formula, again, what I'm doing every time is I'm finding my x coordinates. So starting with x2, I have 7, and I'm going to subtract a -1. So 7 minus 1 squared plus 17 minus 11 quantity squared. So remember that it's minus minus becomes positive. So that means I get the square root of 8 squared, and here I get 6 squared. So that gets me 64, that gets me 36, and I'm taking the square root of that, which is the square root of 100, which is equal to 10. So I now know the length of AB. Now remember, I'm going to treat AB as the base, right? So that's going to be my base for my rectangle. The only other thing I need to find, since I found the length of A to B, is, let's say, BC, right? BC could be the height, and let's use blue for that. So that'll be my base, that'll be my height. If I calculate them and multiply, I get the area. So I'm going to treat B as x1, y1, and C as x2, y2. So BC. Calculate that. We have 10 for x2, 7 for x1, so 10 minus 7. And then we have 13 minus 17 for y2 minus y1. So here I'm going to end up with 3 squared. And here I get a negative 4 squared. So that yields 9 and 16. Take the square root of that, and I end up with a nice 25. Take the square root of that, and I get 5. So the length of BC is going to end up being 5, and the length of AB was 10. So what is the area going to be then? Well, I'll use green for that. The area is going to be the base times the height. The base is 10, the height is 5. So that means I get 50 units squared, right? This is now an area, right? So we have to square our units because we are now looking at 2 dimensions rather than a linear dimension, a single dimension. Alrighty. That's an example of how to find the area of a rectangle in the coordinate plane using the distance formula. Let's take a look at an example and the final example of a triangle in the coordinate plane, and we're going to find its area as well. So the strategy in this particular case is to find the base, which we're going to treat A to C as the base. And if we treat A to C as the base, base B, then we have to ensure that the segment that's perpendicular to it, which is this one, is going to be treated as the height. And that's going to be the altitude, BD, right? So the base is just one of the lengths of the triangle, and BD is the altitude, whose measurement is the height. So now that I know that, I just need those 2 lengths in order to calculate this area. So here we're going to calculate AC first, right? So from A all the way down to C, we're going to figure out what that length is. I'm going to treat this as x1, y1, and I'm going to treat that as x2, y2. So AC, distance formula tells us that the the coordinates, the difference of the x coordinates, we've got x2 is 5 minus negative 4 quantity squared plus y2 is negative 1 minus 2 quantity squared. So here we have negative, negative, that becomes positive. So that means I get 9 squared plus negative 3 squared. So here I've got the square root then of 81 plus 9. And that's going to get me 90, square root of 90. Alright, so we've got that. We've got our length for our base. So our base is square root of 90 and it's ready to go. You know, the area formula below, for example, I'll use green again, is going to be base times the height divided by 2. We now know the base is the square root of 90. So now we're just waiting for the height. So the height is going to be B to D. I'm going to treat that. Let's treat that one as x1, y1, and we'll treat this one as x2, y2. How about that? So BD is the altitude, and specifically actually the height because it's the length of the altitude. And we're going to go ahead, take the difference of the x, so negative 2 minus negative 1. And I kind of jumped the gun a little bit there because it's negative 2 minus negative 1. I want to show that because I want to show that I'm going to change it. If you know that automatically, you can just change it. And then we have another negative 2. In this case, it's just minus positive 1, so there's no negative, negative. All right, so remember here, negative, negative makes positive. So that means I get the square root of negative 2 plus 1 is negative 1 quantity squared, and then here we get negative 3 quantity squared. So that's going to equal the square root of 1 plus 9, which is equal to the square root of 10. So BD's length is the square root of 10. So now I know that I'm supposed to multiply square root of 90 by the square root of 10, and I divide all of that by 2. All right. So what's interesting about multiplying those together is when you multiply the square root of 90 times the square root of 10, you get the square root of 900. And then you can just divide that by 2. So what I'm saying there is that you can actually multiply the numbers underneath since they're both square roots. So that means the square root of 90 times 10 divided by 2. That's going to equal the square root of 900 divided by 2. And that happens to be equal to 30 divided by 2, which is 15. So that is going to be 15 square units for the area of this triangle. Okay, so there we have it. We have the area of the triangle in the coordinate plane, the area of the rectangle in the coordinate plane, and we've also practiced perimeter as well of triangles and rectangles in the coordinate plane. And that represents lesson 4.08 for your exit ticket. Remember, your exit ticket is due tonight at midnight. Good luck on that. If you have any questions, I'm sure your teachers will be willing to assist you. And have a great and awesome weekend.